Some fishing lures float and some sink. We're going to use what we learned about boats floating and some of this equipment to help us predict, test, and explain why these lures float or sink. Dad told me one sinks and one floats, but he didn't tell me which one was which. So let's make a prediction about which one will float and which one will sink. To start with, I'm going to name this one Silver and this one Rainbow. Now, let's look at them for clues to help us make a prediction. The color is obviously different, but I don't think that will matter. The silver one is bigger, but the rainbow one is smaller. What else do you notice? That's right, the silver one has 2 hooks, but the rainbow one has only 1. The hooks are made of steel. We learned in an earlier video that steel can float if it has the right shape. But these hooks look like anchors, so I'm pretty sure they would want to sink. I'm predicting this one will sink because it is bigger and has more hooks. And because Dad told me one would float, I predict this one will float. Let's see what happens. Let's try the rainbow one first. No way, it didn't float. It sank! Let's see if the silver one floats. It's floating! My prediction was wrong. But that's okay because science is about finding answers. And sometimes being wrong helps us understand things better. Let's see if we can understand what's going on. I noticed that despite this one was bigger, they both have had around the same weight. So let's weigh them.
2.84, okay?
2.84 grams.
2.61 G.
2.61 grams. Knowing the mass gives us a really big clue. But we really need to know its density. And to do that, we need to know its volume. To do that, we're going to use a trick Archimedes figured out using water displacement. I'll link to a cool video about that below. First, we add exactly 40 milliliters to this graduated cylinder. Then we drop in the lure. However big the lure is also how much it raises the water level. By measuring the water level rise, we get the volume of the lure. We are going to call this 1.3 milliliters. We'll do the same thing with the silver lure. Because it floats, we will use this straw to just hold it barely under. We're going to call that one 3.9 milliliters. So here is our mass and volume data. To get the density, we divide the mass by the volume. That gives us a density of 2.18 grams per milliliter for the rainbow lure and a density of 0.67 grams per milliliter for the silver lure. The rainbow lure has 3 times the density of the silver lure. Let's see how knowing an object's density can help us predict if it floats. To do that, we need to know the density of water. Density is mass over a known volume. So we took 50 milliliters of water and weighed it. When we plugged the numbers into our formula, we got a number that rounds to 1. Which is great because that's the standard density of water. And it's easy to remember. If an object's density is greater than 1, it sinks. And if an object's density is less than 1, it floats. And that matches our results. But it did make me wonder, what happens if an object's density is exactly 1? Dad says we'll find out next time, so subscribe to see it. See you next time!